The 1,2,3-propanediol, also more commonly called glycerin, is one of the most abundant alcohol found in nature. Very often it's found in ester from oils and animal fat. In laboratory, it's mainly used as a highly boiling solvent. In fact, its boiling point is equal to 2090 degrees centigrade, which is decidedly high. It is colorless liquid that tends to take a slight yellow when it's going to contact with atmospheric oxygen. Thanks to the slight polarity given by the three groups OH, the molecule is perfectly mixed in water, with which form a solution that follows a very strange bubbling curve based on its relationship with it. Is ether and ester, or of an elementary form, can be used to a building blocks in organic chemistry. To extract in this video we start from the smoke machine liquid. According to the technical specification of the liquid, I would have expected to extract propylene glycol. However, for reasons that's defined later, I found some glycerin. Let's start with the data I found during the video recording. So let's start with a solution with the volumes on volume percentage reported here. Let's move on to the practice. We start putting 1 liter of solution in the bowl. If you can not make a mistake and fill it for a maximum of 2/3 and start to ease. During the distillation I collected experimental data by taking quantities of distillated water and relative it to the boiling point temperature. From this came these graphs. I can be noted that unlike the red curve, the expected ones, our curve gradually begins and increases exponentially with the increase of the distillate. When I reach 188 degrees centigrade, which is the boiling point of propylene glycol, I changed the collection vessel. However, the temperature continued to grow up until I was uncountable for what happened, from which time I trusted that the temperature would stop at 2090 degrees, and luckily it was. Now I explained briefly during the time lapse what happened. The smoke machine's liquid was enclosed in a broken container that had an opening due to a break on the top, to slow down the recirculation of oxygen. The oxygen has oxidized the propylene glycol, also taking the less carbon, thus leading to the formation of glycerin. So I separated the distillate fraction in the first expression to the most water. In the intermediate, I expect a mixture composed of propylene glycol and that has not yet been oxidized. A last fraction I hope to get glycerin quite pure. I take into account that the waste will all remain in the distillation flask. Before seeing the distillation, I participate in the interaction of glycerin with water. The different refractions give rise of this distortion. In this clip, we see the dark liquid that's as reminded to be distilled. We therefore obtain 4 phases shown here. To check my thesis, I took a 100 ml sample and weighted the net to determine the density. In this way, I go to verify with a constant the identity of the compound that goes to add to the boiling temperature. In the end, we get this result. In the first distillation, we have a density of 1.002, which makes me think that is mostly water. In the second part we have a density of 1.028 that's approached to the density of propylene glycol. Although I can deduce from this higher density that this fraction is slightly contaminated with glycerin. The final phase have a density equal to 1.265, which is very close. Facts wrong to the high temperature. In fact, the liquid was certainly not at 20 degrees centigrade, or residue attached to the cylinder. The last phase, the remaining one, is irrelevant, but it wanted to calculate the density for personal whim. Now proceed to transfer everything into a container, even plastic is fine, and let's write what's inside. Thanks for watching. Remember to follow my channel and comment if there is some questions about these videos.